Hello everyone, welcome. Hopefully you guys are starting your week on a good note. It is Monday after all, so if any of you are in school right now, hopefully you're focusing on your classes diligently. And if you're basically just working on some homework on the side, hopefully my stream will basically help you feel more productive in the space that you're in. So, let us get into it, shall we? Alright, so I think for today, I just wanted to actually start off on actually building some structure here. So, I thought that probably I would just start off studying certain books that I find very interesting towards the goals that I want to set up for myself. So I thought I would actually just take a look at some of the books I have. So the first book I'll just drag it for you guys so you guys can see it. So the first book I want to look at is The Mathematical Methods of Physics and Engineering. But usually I have a couple of books here, so let me just actually drag all of them onto this little window here so that we can actually see them all. So some of them are a majority of them are proof-based, but this particular book I actually want to focus on the most because obviously it has a ton of awesome information in it. At the same time, I know not everything is covered within the preliminary stuff, but I do want to be able to actually learn from this book. I think like my long time goal, I don't think will like, this will take like years, but I really want to fully like understand this book, like all the way up to the last chapter of this book. So I guess that's like the primary purpose of like, I guess like the whole entire stream. Well, the whole entire like channel actually is just to understand the methods in this book. So that's the primary goal. So, but we also have to learn some math proofs. So we're also going to do learn from this book. Let me just zoom out of here because it's like really close. How to read and do proofs. So I think I'll just like skim through. Well, not skim. I'll read this book and write down the notes that I discover in this book. But I can't keep the books like on like the same screen as what I'm learning. So I think we're just gonna basically just keep it like in where we're at. So I also have Udemy on here, but I made it sure that my browser's audio is not audible to you guys because obviously it's Udemy and I don't want to record any of the stuff or like actually have it on stream to basically like be caught, because obviously the creators that basically made each of these courses on Udemy, I want to respect their content, so therefore like I can't have the audio like bleeding out onto my stream. So I made sure that the audio from my browser doesn't come onto your screen while I'm streaming, but I will be writing down notes if I have to like watch any of their stuff. So I think we're just gonna get into some proof writing, but don't worry, I will have the music playing. The music is playing on a separate player, it's not playing on my browser. So let's get into it, shall we? So I think we're just gonna start taking notes here. Hello, Breath Deeply. How are you doing today? What's the best part of your day so far? You're good? Cool, cool, cool. Yeah, basically I'm just like listening to lectures and taking notes right now. But I'm basically doing fine. Shoveled some snow. Basically got a workout done. Can't complain. What are you up to? What are you up to, deep? Breathe deeply. Let's see. About to start doing my homework on math. Oh, okay, cool. If you don't mind me talking to you while you do your homework, I don't mind talking to you. But if like the music or my voice is like distracting for you, you're free to mute me and I'll just like work on my own thing. Whatever you decide, just put it in the chat, and I will do my best to accommodate you to give you the proper study space. No, it's okay. No problem, no problem. Because, like, for me, I'm a hobbyist in math, so I don't mind talking to people while I'm doing the math and listening to lectures. I remember that proof I did 2 years ago. At least you have experience with proofs. I'm trying to learn proofs now, actually. I'm not a student, by the way. I'm just doing this on my own, just for fun. Yeah, I have read your bio. Oh, okay. Thank you for reading my about me section. I don't have like a full out schedule yet, but I think I'm going to be doing these streams like from Monday to Wednesday at the same time that I'm doing it now. So if you would like to like, yeah, those inequalities are very useful. Ah, I see. Yeah, like I think for me it's like I'm trying my best to like actually understand math proofs because I've never been exposed to them. Like I know the symbol, like, you know, like I've read like, I guess, like intro to proof books, and like, you know, I know what a set is. Well, I think that's the wrong way to say it. I've seen what a set is, and I've seen what, like, you know, the symbol for it's an element of, like, symbol, and, you know, the fancy symbols for the other sets, like, you know, the natural numbers and stuff. But for me, it's like I have never really experienced like actually proving proofs, and, you know, and I think that's basically the way to get my feet wet. Yeah, this is the hard step in math. Yeah, because like my goal, I don't know if you were like lurking in the beginning of the stream or whatever, but my goal is to actually like be able to understand this book, Mathematical Methods for Physics and Engineering. But I want to be able to like understand, like, I guess, theoretical physics equations, but as like I guess like how mathematicians view math, you know. Nice goal. Well, it's an ambitious one. It's an ambitious goal, actually. Let's see. I gotta write my time here. Oh, I don't even have my pen with me. Oh, shoot. Like, I will be right back, guys. Just give me like a minute or two. Alright guys, I'm back. Sorry about that. I think we were like on 27 minutes, but I'll just basically just study like with the time, because like the problem with this timer I have on my screen is that like I don't know how to pause it, like how to actually like interact with it so I can pause it like whenever I need to use the bathroom. So it just restarts itself whenever I restart the stream. So I'm sorry if my English is not good. Oh no, it's okay. It's okay. It's okay. Which part of France are you from? If you don't mind me asking. Because I know someone from France. Like I think she used to live in Paris, but then she moved to I think more of the countryside, more of the like suburbs, I think. Now where was I? Oh yeah. And actually, what are you studying in school? Breathe deeply. I actually like your name, by the way. It's like good, like kind of like meditation, like feels like deep meditation type of name. Welcome back, Deeply. Breathe deeply. Hopefully everything is okay on your side of the world. What's the program that you have in math? Is that what you're asking? I'm just basically using Microsoft Whiteboard right now. I don't have like any fancy like note-taking like programs. It's just Microsoft Whiteboard. Nothing fancy. Nothing fancy. I mean, the schedule. Oh, okay. So I think, like, I haven't put it in my info yet, but I think my schedule for this channel, because I also have another channel I stream on whenever I play, like, video games and stuff. This channel, I believe it's going to be Monday, Tuesday, Wednesday at, like, it's going to be 2 p.m. to whatever time I choose. Like, I don't know how long I usually study, because before I would do it for 45 minutes and I would talk to you guys for 15 minutes and then that would be stream. But, you know, like, if I study longer, you know, the sky's the limit. So I think, like, maybe, like, 2 p.m. to 4 p.m. Eastern Standard Time. Because I live in the US, so I'm on the East Coast. So, yeah, so I think, like, I'm guessing you live in France, right? Because you said you were French, right? Because I think you guys are, like, maybe 5 hours ahead of us? I believe that is the case. If I'm wrong, please correct me. Hopefully what I said you understood, because I know you said your English is not that great, but it's okay. Your English is what I can understand the English you're typing out, so do not worry. I think your English is much better than you think it is. Hopefully, you were able to understand what I said. If you didn't, please let me know and I'll repeat what I said. I don't mind repeating it several times. So we got through most of the lecture stuff. Let's just look over our notes so that we can understand stuff before we actually do some problems, actually. Because, let's see, we took notes on we know what unions are. This stuff, like, I've practically, like, read a lot in books. So I know what a set is, I know what the union is, but I just want to double check just so that I can get. So a union, if you're written as set notation, is X is an element of A or X is an element of B. It could be both, or it could be like either an A or an B. Then an intersection, it has to be A and B, so that we know. Okay, so let's look over the proof of the triangle inequality. So, equality proof. Let's see, for all x, there's all x is an element of the real numbers. So the absolute value of the square of the absolute value squared is same as saying the square of x. Okay, that's good to know. Okay, so we squared those, so it's same as foiling, or PEMDAS is the regular operations. Okay. That's squared. So take the square root of that. Okay. The one thing is that I don't know which scratch work you actually put into the proof and which ones you just leave out that are obvious. Let's see. So minus. Okay, maybe I have to look over this part, because he didn't, the person that was lecturing didn't put that, actually. They said, like, they said a bottom part here, so maybe I have to look over that proof again, just to make sure I understand what that is. So according to the lecturer, it's basically the same as this when you write it down. Okay. Oh, it's just reverse. Okay, that makes sense. All right, now scroll down here. Let's see the proof. Okay, so the absolute value. Oh, okay. So you take it apart. Then less than or equal to. Yeah, less than or equal to, yes. Here, subtract b on both sides. here. So then that would be... Oh, okay, okay. So my mind is basically telling me that if it's like this... Oops. I always hate it when I don't write very great for you guys. And it's like... Oops. So it's like that, and then plus negative there, and then plus b, then minus b on both sides. Technically these would be both considered B. So then, but then this is negative, so outside is negative, so positive B. What I'm stuck at is that I'm trying to like understand this part because they're both gonna become B, but the thing of it is that because let's see, negative B. You can split that. Because I'm trying to make sure I understand this proof before I actually like do some problems. Because otherwise then I'll be left to like basically like because I feel like this is 0, but at the same time like you need to turn this into this. And I feel like there's a gap in my mind on why that happens. If anyone in chat like can give me a little bit of an idea, just let me know. just type it into chat if you like. Because I know like if it's the absolute value, then it's gonna be the same. It's just gonna be like, you know, B. Because like whether it's negative or whether it's positive, it's always gonna be B. The thing is that then this negative's in front, and if I do minus B, then basically this makes this 0. Because I think, yeah, this is supposed to turn... Oh, wait a minute. Maybe these two B's like cancel each other out, and then you're just left with this. Well, yeah. Oh, I actually wrote that wrong. go. Minus b. Okay, that makes... Okay. So I kind of psyched myself out because I keep thinking that this b is not going to be, like, taking this b out. But I think, like, in the way it's supposed to be understood is that this b is going to take this b out, and this b is just going to be, like, put into that absolute value of a. Okay. So... Oh, then you try to do the same thing for b. Separate it. Okay. Okay. Let's see here. Yeah, that looks like it's about the same, yeah. Okay, so that's how that proof works. I mean, like looking it over, I feel like I'm understanding the logic within the structure of it. So absolute value, I just want, yeah, because I remember this definition of the absolute value right here. So right here, the absolute value of this, yeah, which is like if it's less than 0, if it's greater than or equal to 0, if it's this, if it's less than 0, then it's going to be like this. Hence, it's going to be like that. Yeah. Okay. Alright. Let's see the Bernoulli inequality proof. Let's see what this is. Prove that a plus a 1 plus a to the nth power is greater than or equal to a plus na. Interesting. For all a that is greater than or equal to -1. Okay. Let's see for all of... Like, I'm just reciting these because even though I've taken notes on it, I just want to recite it in my head so I remember it better. Proof, suppose that a is less than or equal to -1. And then we have the base case right here, which is what we need to prove. Because we're using proof by induction in this one. Now, I haven't formally practiced, like, you know, direct proof, proof by induction, proof by contradiction, proof by counterpositive. All of those stuff I haven't done. So, it will be a first for me to actually engage with it. Like, I know what proof, like, I've seen proof by induction, but I haven't fully, like, practiced it. Like, the proof techniques, I haven't fully practiced them yet. The induction hypothesis. So suppose, or something. So the induction step, we have to show that. Okay, so on this side. Which in turn turns into that. So let's see, they're greater than or equal to 0, which we can drop here, and then which in turn is practically the same as, okay, yep, I think I kind of understand that. So now let's actually do some problems. And luckily, the lecturer provided us 3 problems to work with. Inequality. Oops. They're inequality problems, so hopefully we can understand what these questions are asking. Okay, problem number 1. Let A be positive let A be a positive number. Prove that if x is a real number such that then a is greater than. Okay, so let a be a positive number. Prove that. So I guess suppose a is an element of the positive integers. Prove that if x is a real number and x is the element of a real number, x is an element of a real number such that the absolute value of x minus a so the absolute value of x minus a is less than a over 2 . Okay. So now we have to prove this. Okay. Prove that x is a real number. So x has to be a real number in this case. Just want to make sure. So suppose that a is an element of the positive integers. Let's just make that obvious. So that's that we defined, and x is an element of the real numbers such that so we have to prove this mainly. Okay, so now my question is x supposed to be greater than a? Because it is a minus sign, but then again, if it's a real number, it could also be a negative number. And it's supposed to be a real number, so it could be practically any number at this point. This is where the real challenge begins. And I guess this is where the fun engages. Writing the proof and then basically trying to figure out how to start. Although I don't know if this part here, I think this should be defined, because then that way we know what we're working with. But I think this belongs in the end. The part that I underlined here, because that way we have to show that a is greater than a over 2, which is typically true, because you're taking half of a. Now, so we have the triangle inequality, we have the reverse triangle inequality, and we also have the Bernoulli inequality. this require us to... Which one of those proof techniques does it involve us doing or using, actually? Because I get a feeling it's the Bernoulli, so we might have to do induction here. So if we have the base case... base case. Let's say k is an element of the real numbers such that k minus a k over 2 with 1 and 1 minus a it's not a positive integer. Maybe a is not, because it says a positive number, so it might have to be just a positive real number. Because it says just let a be a positive number. Because I get a feeling it might be just a positive real number. Prove that x is a real number such that x is... Yeah, this is why proofs is really difficult, because you actually have to think about everything and prove everything like rigorously at this point. Because it's an absolute value. Oh. And... Yep, break time. We'll probably do another 45 minutes, so I will be right back, guys. I'm just gonna leave the clock ticking, but I will be right back. Alright guys, I'm back. So this is break time, so I'm free to chat with you guys until we start the next study session. And I think the next study session will probably be like basically just trying to figure out these problems here. Because we only have 3 problems, but they're proof-based problems, so we need to use proof techniques, the proof techniques that we take a note of to actually solve these things. So, but at the same time, like, we just have a 15-minute break, so we're free to chill. Hopefully you guys basically got some work done. I know we basically studied like a lot longer than anticipated. I'm guessing like probably like 47 minutes or something like that, but you know, we took our time with it. Or maybe we studied like for like about like maybe like close to an hour, I guess. Yeah, like on my OBS it looks like it shows it's about like an hour and 16 minutes. But then again, like, you know, there was times when we just did the startup and all that stuff. But, you know, hopefully you guys got some like good work done over the course of that hour, I suppose. Usually like because I don't want to skip out on the problems, because obviously I need to practice more problems. Because the reason why I'm doing proofs is because I know like theoretical physicists, like they really need to know proof techniques in order to, like, you know, prove like things within the mathematical physics part. So, you know, I just feel as if, like, you know, if I'm gonna have fun with like physical equations, I might as well learn the techniques that mathematicians use to prove rigorous operations. Or like rigorous ideas, I should say. But yeah, like this problem is very intriguing because even though it feels like I don't know how to start it, it feels as if I'm kind of like, I kind of have an idea. It's like, it's sort of close. Like the idea of like looking at this problem is like I'm trying to reel in exactly what is it that I need to do for this particular problem. I'm not going to say it's easy. I'm just basically feeling like it feels as if like the method is like kind of creeping up in my head. I don't know if it's right or not, but at the same time it's like I feel as if it's like kind of there and it's like slowly seeping in on what exactly is it that I need to do, you know? You know. Oh, hello, and Stunky. How are you doing? I went live at the same time with the linear algebra class, so I missed you. No, it's okay. It's okay. I'm guessing you came from Penn Center, right? From Penn Center stream. Are they still streaming their linear algebra class? We're good. Cool. Actually, that is a lie. I was nervous. I didn't sleep at all last night. Oh, I'm sorry to hear that. Yes, it's still going. Okay, yeah. Yeah, Pet Center, like, I saw his lecture on real analysis. I thought that was really, really cool because he explained it so eloquently. Now, like, I'm basically just chilling with you guys until I have to do the next study session. We're actually going to go for another study session. So, hopefully we'll be able to figure out how these problems work. Actually, and Stunky, like, are you a student? Like if you're a student, like, you know, what are you majoring in? I'm just curious. If you're already like, oh, not anymore, / not yet. Oh, okay. I see. So I'm guessing you have a bachelor's degree? And if you do, like, what is it that you got a bachelor's in? Previously math, future accounting, maybe. Oh, okay. So you're going the finance route with your math. That's not bad. I mean, like, the thing of it is that it's kind of cool that, like, people that were physics majors, they can get into finance because, like, they have a lot of mathematical background and they're able to look at data. So that's pretty cool. I'd like a CPA certification. Oh, nice. I wish you luck. Because, like, actually it's kind of cool that, like, people in the finance world, especially, like, if they came from a mathematical or science background, they're able to, like, make a lot of money. It was probably not the field they intended to go. They probably wanted to be a scientist or, like, someone involved, like an engineer or something. But then they ended up getting into finance, which is not a bad move. I mean, I think a lot of math majors, they would probably prefer doing something that makes a lot of money. I think being an actuary takes, like, a lot of work, though. Because I think, like, most math majors, if they're getting just a bachelor's in math, they probably would aim for, like, actuary or, like, something related to finance. I've been doing my own taxes anyway. I have had to look into business nonsense for Twitch, and I'm like, I'm unemployed. Yeah, like, you know, I still do my own, like, I do taxes through, like, like TurboTax and stuff. So, you know, for me, it's like obviously I'm not making income, but at the same time, it's like, I still file because, like, obviously I'm still getting my health benefits from, like, certain programs. So, I have to file those. But luckily I have some investments as well, and still money in the bank. That makes sense. Yeah. Yep. There's things you can't avoid in life. You can't avoid, like, diseases, you can't avoid death, and you also can't avoid taxes. Don't do that, guys. Always pay your taxes. Don't try to be clever. Don't try to be cute. You'll be better off just paying it. But yeah, like, I'm actually trying to do, like, so, like, Nstunky, like, I actually set up a goal for myself. Well, I hate using goals. Like, my intention, like, is basically, I want to be able to understand this book. Which is the mathematical methods for physics and engineers. But of course, like, I'm doing proof techniques because I know, like, theoretical physicists, they have to know at least some basic proof techniques. So, like, right now I'm actually just doing, I guess, like, the bare minimum of, like, because I'm taking, like, I don't know if you're familiar with Udemy, which is, it's kind of like a learning website where you can, like, pay for a course and then you can take the course. And it's a lot cheaper than, like, going to college. So, the Math Sorcerer actually created a real analysis course on there. And, like, I'm actually doing, like, one of the problem sets that he set up for that course. And the proofs that we went over were basically the proof of the triangle inequality, the reverse triangle inequality, and the Bernoulli inequality. So I have to use the knowledge of those inequalities to basically solve these three proof questions. So it will be the first time I'm actually engaging with an actual proof question that's in real analysis. And I haven't even taken, like, an intro to, like, a proof writing course. So, this is me, like, I have not mastered, like, proof by direct proof, proof by contradiction, proof by induction, proof by counterpositive. I have not mastered any of those. I know about them, I have never practiced any problems involving those. Like, I know what a set is, I know what an element is, but just because I know, I'm familiar with the definitions doesn't mean I fully understand what they are, so, yeah, so Bernoulli's is one of those inequalities that's like, this looks way too weak to be useful, but the were you trying to type something there, Nstunky? Like, it looks like it just says the N, or then. Were you trying to type then or something? Or then N? I don't know what that last part is supposed to mean. So I'm guessing like you're supposed to use those inequalities to like solve better problems. Like I know you have to use the triangle inequality in real analysis, but obviously I don't have experience like actually engaging with it, so you know. Because like what I like about the book Mathematical Methods of Physics and Engineering is that they kind of introduce like some stuff. Like they introduce you to algebra, but they don't go over the algebra that much. They just go over, I think, like polynomials, and then they show like some interesting way of writing like the zeros and stuff, which I don't understand yet, because I think like there's like a section called the property of zeros, like, you know, trying to figure out the zeros of a polynomial, and I think they would like write like I think they would write like a capital pi for certain sections. Like I could probably like go over it a little bit. Let me just drag this here since we're still on break time. Let's zoom in a little bit. Hopefully that's big enough. Maybe I'll zoom out a little bit. So that's a clunky book. Yeah, it's a really big book. I actually have a physical copy. It's really huge. It's like 1,000 pages. So the one thing I am not getting with this is, where is it? The property of roots. This I'm not understanding. Like I don't understand where this comes from and how you actually calculate this stuff. Because I know what the summation symbol means, and I know what the product symbol means. But I don't fully understand like how do you actually get the roots for this. Like find the cubic equations whose roots are... Like I know you're supposed to use this summation like over this sequence of summations. I guess like that is like the more detailed definition of that. Well, that is harder. Yeah, it is pretty hard. Yeah. Yeah, both zooms are readable. Oh, okay. I just want to make sure that my VTube model is not blocking it. That's why. But that's basically what I want to get through this hurdle first, because in this section it's basically the algebra part where you go through like the properties of zeros. Then you go through the trig identities, which I haven't memorized. I only know some of them. Then we go into coordinate geometry. I actually have to go over these. I have not taken, like, even in my pre-calc class, like when I took pre-calc for the first time, I have never taken these. I mean, I've never gone over those. Like conic sections. I have not gone over conic sections. Partial fractions. Okay, so our break is over. But before I engage with another study section, guys, and you guys are free to talk to me while I'm studying as well, because I'm still a hobbyist at math, so, you know, I don't mind talking to you guys while I'm actually trying to engage with the problems. Maybe talking to you guys will help. Oh, I didn't know my clock restarted. But I will be right back. Just give me a second. I will restart the clock when I come back. Okay guys, I'm back. Let me just restart the study timer. Okay, I'll probably put you in the background until the end of end of class. I should catch you in this section still. Okay, no problem. Thank you, and Stunky. Okay, now we actually have to do this problem now. Seriously. Okay, let A be a positive number. Prove that if X is a real number such that the absolute value of X minus A is less than A over 2, then A is greater than A over 2. Because I'm guessing that A is a real positive number, because it's supposed to be a positive number, but it didn't say it was an integer. And I think, like, if we actually engage, because knowing what we know now, because we have the triangle inequality, we have the reverse triangle inequality, I feel like this is not a triangle inequality problem. I feel as if this is more of a Bernoulli inequality problem. Which the Bernoulli inequality problem is, well, I'm probably not even using the right terms to define that. Because the Bernoulli inequality says that prove that is greater than or equal to 1 plus n for all for A is greater than or equal to -1, and for all n that is positive, that is a positive integer. Okay, so we know that to be true. So do we have to use it to actually solve this problem? Because the absolute value, I mean, with absolute values, would it be a triangle inequality, like, related? Would we have to use the triangle inequality? I mean, I think more likely we could. Oops. I had to erase that, actually. Yeah, maybe I'm thinking of this problem wrong. But actually, I should probably... I'm gonna drag this to the side a little bit, because, okay, so we're right here. So, I'm gonna write all the problems from the sheet, so that way, I can, like, keep them all in front of us. So problem number 2 is let A and B be oh dang, my handwriting, be numbers such that A minus B is less than or equal to 1. Prove that the absolute value of A is less than or equal to B plus 1. Okay. I'll just drag this to the side here so we can write number 3, because there's only 3 problems in this set. So I don't know if we're going to solve them all on stream, but we will try. We will try. We got like 40 minutes. So I know math problems, they could be very, very hard, especially with proof-based math problems. I could probably be staring at it like the whole stream and like not get the right answer or get the right method. So B numbers numbers such that the absolute value of C is not equal to D, the absolute value of D. Prove that the absolute value of A plus B over C plus D, plus D is less than or equal to the absolute value of A plus B plus the absolute value of B. Ooh, the absolute value of C minus the absolute value of D. Oh, these are a doozy. Okay, now the hard part. Thinking of how to solve this. So we have to suppose that A is an element of the real positive numbers. And X is an element of the real numbers. So X is an element of the real numbers. Yeah, we have to include that part, I think, such that the absolute value of X minus A is less than A is greater than A is greater than. Okay. Whew. All right, so let's take a look at what the triangle inequality says. Okay, so the absolute value, of A plus B is less than or equal to the absolute value of A plus the absolute value of B. So let's take a look at what the first question is asking. So the absolute value is less than A.5. What does the reverse triangle inequality says? The absolute value of A minus the absolute value of B is less than or equal to the absolute value of A plus B. Okay. And the Bernoulli inequality for all the integer, A is less than or equal to -1. So is it a Bernoulli inequality proof? Dang. The hardest part is actually figuring out what type of problem it is. I guess it's similar to how, like, it's hard for physics when you're trying to figure out how to turn a word problem into a math problem. But of course, math wouldn't be rewarding if it wasn't challenging. And of course, real analysis is usually the real test of mathematical rigor and maturity. I just hope, like, the whole stream is like not me just staring at a problem and just basically are like, I haven't written anything down yet. Because the thing of it is that, I mean, if a is a positive integer, then technically the absolute value wouldn't matter, because then it will just, even if it's a negative, it'll just basically be a positive number. But then, like, how would it be less than a1/2? That's the thing, though, because we have to prove that x is a real number such that so it's revolved around a, and a has to be a number where if x is a real number minus a, the absolute value of those two combined, well, the difference between the two and the absolute value of that difference is supposed to be less than a1/2. So when we have to think about that, drop my pen there. Like, I feel like I'm getting into the real detail of the problem now, because we have to prove that there's an x. Prove that there's an x where, so it's kind of like we're looking for a specific, not a specific value, but sort of like a specific condition, as it were, for x. I mean, obviously the condition is what I just said, but it just feels like we're getting a little bit closer to understanding how this problem is functioning, I think. Or maybe I'm fooling myself when I'm just thinking very hard. And a is supposed to be greater than a over 2, which is usually a given. Usually. Unless, like, a is a fraction. Maybe I should copy this. No. Oh, no, that's not what I wanted to do. Here we go. That's what I want. I just want to copy this, though. I don't want to... just copy it, please. Oh, no. Just drag this down here. Can I paste this? Yeah. I'm just leaving this on the side so I actually can see it without having to scroll up too many times. Let's put it over there so I can see it. Okay. Okay. So Bernoulli's inequality tells us that is greater than or equal to. I don't see how that helps us, though. Let's try number 2. Let's try number 2. Maybe we'll have our brain like work that problem in the background. Okay, so let a and b be numbers such that a minus b is less than or equal to 1. Prove that a is less than or equal to b plus 1. Okay. All right. So suppose, suppose and I will also post this VOD on YouTube, guys, so that way we can keep this moment for historical accuracy. Suppose A and B, we'll say, are real numbers such that A minus B is less than or equal to 1. So we have to prove that A, the absolute value of A, is less than or equal to B plus 1. So A is equal to A plus B minus B. That is equivalent to A plus B plus minus B. Yeah, I think that's accurate. So then if we have A plus B minus B, then okay. So now we have what A is. Dang. Now I'm trying to think right now. Because I had a thought and it just basically just disappeared from my head. Because if A is basically just A plus B minus B, the absolute value, but then we just do this. Because I'm thinking back to what it was for the reverse triangle inequality. So would it be B plus 1 here? Because I'm actually going reverse. I just defined what A is and I'm like, am I doing the right thing? Am I? Because I'm actually kind of proving this through this. I don't know if that's the right technique though. I'm probably doing this completely wrong. Because then, like, why would you do it backwards? Because I'm supposed to prove this with this, I think. Maybe I have to do it with maybe I have to do it with this. So if A is, because it's supposed to be A minus B. And because I'm kind of proving the reverse here if I do it the way I thought I was going to do it. Because I don't know if you can prove it that way. It just felt kind of off. I don't know. Because, like, if you have A plus B plus minus B, the absolute value of minus B, could you do that? Where's the, here it is. Yeah, because the way they defined A was like that. It's like I get like kind of close, but at the same, like, I'm not saying close like I'm close to the answer. It just feels as if like I feel like I have a method in mind, but at the same time it's like it feels like it just slips away from my head. Maybe, oh, no, erase this. Maybe rewrite it like this, plus B. So let's just rewrite this, plus B, then, so A minus B plus B which then can equal 1. Is that it? Is that actually what we had to do? Because then if that is equal to 1, I think that's it. Because then A is still less than or equal to B plus 1. I think that's it. Now, how do you write that as the final sentence, though? I mean, if I'm wrong, let me know if I'm wrong, guys, because I feel like that's right. Because, like, the way A is defined, we could define it either, like, you know, A minus B or B minus B, like, or A minus B plus B. Which it seems like it's right. But if I'm totally wrong on the proof method, let me know. Because I'm like, it feels like I got it. I feel like it, but at the same time, I don't know if that is the right way of thinking. Thus... I guess we'll consider that done, I suppose. If I'm completely wrong, let me know, guys. The first line should be... are you talking about this line? Oh, whoops. Are you talking about this line? Is that the line you're talking about, Enstunky? Yeah, that line. Oh, okay. Supposed to be... Right, yeah. So, okay. Oh, okay. Okay. Yeah, I was fixated on what A was. Oh, jeez. That got, so there's another, less than or equal to that got missed. You find that one. I don't think I found it though. I thought it was there, but I don't know. That might be the wrong one. It is the wrong one. Keep checking. Right here? Because there's only two places it could be. Yeah, so why? So I think the reason why you said that is because what I was thinking is because the reason why I had an equals there was because I was trying to continue on the thought process of what I was thinking here. That's the reason why I put an equal sign, because I'm so used to doing that. Like, you know, when you do calculations, you always put equals all the time. But I'm thinking the reason why you put it there is because it's still, this A is kind of considered going down here. That's what my assumption is. That's the reason why you kind of warned me about that. Am I correct? The second bit, not quite. Oh, okay. Yeah, because I wasn't real, because the way I was thinking, and I think this is common with calculation-based math, is that I am so used to using the equal sign when it came to like just continuing on a problem, because my assumption is that, because I'm thinking basically the way this is structured, like this first line, is that, how should I say it? I had the thought in my head. Like, I was thinking that this part is a continuation of this. So, like, I would think it's a continuation of something. But instead, like, instead of just being two separate things, like two separate parts of the of the inequality. Yeah, that was the part that hit me, because I was like, wait, a minus b, and then put that plus b plus the absolute value of b, and then like, definitely you're putting the puzzle pieces together properly. Oh, okay. Well, I appreciate you giving me the support. So like, is this right though? Is this how the proof is supposed to be structured? You're just putting the wrong paint on top. Let's see, but you only know that you know that it's equal to 1. Yes, it looks like an accurate proof. Okay, well, that kind of gives me a little bit more confidence then. I just like looked at it and I was like, wait, this looks funny. It looks funny, and at the same time it looked like there was something I missed, and I was like, wait, maybe I have to do something different here. Well, that gives me a confidence boost. So the proof looks accurate. Okay. So what did you mean by the wrong paint on top? Like, to put a calculational spin on it, try A equals B equals 2. Okay, so they're both equal to the same number, so basically that would be 0. And then, which equals 1. But then, if you have, then A would be less than or equal to B plus 1, which is like, that's 3. Okay. Alright. Okay. Less talking, more writing. See what happens with each step. So you said replace like 2 with A. So then that would be A minus B plus 2. Which then goes into A minus B plus 2. Then over here, it would be A minus B plus 2. Thus, it would be like this, A minus B, which would result in the absolute value of 2, which would then give us the absolute value of 2, well, will give us 2 is less than or equal to 3. Unless I'm writing it wrong, from what you're suggesting. Because like the way it looked like, I was like, where is this gonna end up? And this like, oh wait, it says A is less than or equal to 3. Right, so the thing I'm trying to point out here is some steps, nothing changed, but some steps you actually need the flexibility of not being exactly equal. Oh, okay. That's fair. Okay, so we managed to do our first proof. I'm pretty surprised about that. Okay, now I'm I'm not saying I'm completely confident, but I feel like I'm actually feeling like it's not as intimidating as I've made it out to be. Because this is how I solve puzzles. Like, whenever I solve puzzles, like, I just mess with it, and then suddenly, like, I see something, and I'm like, wait, is this supposed to go here, and this supposed to go there? It's like, I haphazardly solve things, and I don't, and sometimes I solve it without even knowing I solved it, and I'm like, oh, that's what it's supposed to be? Proof achieved, yeah. Well, actually, it was thanks to your instruction, and Stunky. I really appreciate your feedback. Because, like, I know that I'm not going to understand math proofs as, like, you know, from all the other, like, people that, like, know how to do this stuff. But, you know, I'm just trying. And I think that's the most important thing. Okay, let A and B be... let A, B, C, and D be numbers such that C is not equal to D. So, suppose... Now, I'm guessing they're supposed to be real numbers. That's my guess. So suppose A, B, C, and D are elements of real numbers such that the absolute value of C is not equal to the absolute value of D. Okay. Now, I mean, is this the same? I don't think it's the same, is it? Should be, right? This is what I get for, like, not remembering algebra that well. But then again, like, when I practiced algebra, it was like a long time ago. I feel like that's how it works. Unless, like, I'm totally, like, messing up on, like, absolute values. Because I feel like it's the same as, like, if you put a parentheses and it's squared. We'll do what mathematicians do. Assume it's true. Let's assume it's true. And then I'll probably get yelled at by you guys and say, it's totally wrong. Oh, my music stopped. I didn't realize that. I have to give the proper atmosphere. There we go. Alright. So we have absolute value of A plus absolute value of B. I think this is mostly scratch work though. So if we have this, I mean, this is also scratch work, but do I have to write the definitions of every one of these absolute values? Actually, because I'm trying to write the resultant of this, actually. feel like these might help me, but I don't know yet, so we'll just... I guess this is considered like scratch work, this part. So I guess we're gonna have to try to turn these into this. That's my thought process here. So then plus maybe you have to rewrite these. And we're out of time. Well, at least we got one proof done. I would say like that's a pretty good achievement for stream. Getting one proof that I'm probably not going to forget this problem, actually. Because it's the first proof I actually achieved on stream. But, you know, I can't get too cocky, though. This one, I feel like we're kind of getting close. We're getting close. But I am not particularly sure if I'm doing the technique right, though. Or maybe if I'm solving the wrong side here. I mean, I know it's break time, but I'm basically, like, just... Like, we already got, like, 2 hours, and we basically just, like, only doing 3 problems. But I'll be right back, guys. Just 1 second. Just popped in for that comment, but yeah. What's classic? I feel like I'm sort of having a better idea of how to approach this problem, but at the same time, it's like I don't want to get too cocky, because usually, like, I don't want to feel like, oh, I know this, like, I know how to do this, and at the same time, it's like, nope, you're still not there, buddy. But I'm kind of glad, I'm really glad that I was able to solve my first proof on stream. I mean, with your help, of course, and Stunky. Cause like, I'm like right now, even though it's like break time, I'm like thinking about what is it that I need to do, because like I feel like I want to get all these problems done because we have like 3 problems only. So I feel like we're getting close to actually having like, I guess like a, not like a breakthrough, but I feel like, wow, I'm actually understanding a little bit of like, I guess not the basic, but I guess like sort of like the vague idea of what I'm supposed to cover in this first part of real analysis. Oh no, I get that though. Who is your favorite Mirror Glasses anime boy? I don't know, because like the thing of it is that like there are so many like epic like characters that do like the typical glasses shine before they do something epic. I can't think of one right now. Because actually when I think about it, my favorite like anime characters, they don't wear glasses. Maybe the main character from what's the anime's name? The World God Only Knows. He's the only one I can think of right now that wears glasses. But then again, like I wouldn't say he's my favorite though. I mean, there's so many epic characters that wear glasses, but then again, actually, like, I think from a game, my favorite character that wears glasses is Welt from Honkai Star Rail. I would say he's like my favorite. He would probably be my my favorite shiny glasses boy. Or more like Shiny Glasses Man. He's my favorite character. I also like his line from Honkai Star when he does his ultimate. It's like, survive or be destroyed. There is no other choice. But yeah, like, I think the thing that really incites me about mathematical proofs is that it feels as if you're kind of like conjuring up something, but it's all in your head, mainly. Like, cause the reason why I got into math is because of physics, but the reason why I got into physics is because I wanted to create a novel that was about like main characters using like physics equations to manipulate the world around them, like magic. But of course, like, you know, like there are conundrum questions like, where does the energy come from for them to actually create these mathematical spells? What is it that powers their ability to manipulate the forces of nature without violating the laws of violating the conservation of energy? You know, all these different questions, and you know, I still don't have the workaround around it. Like, you know, like I can read a lot of books about the layman's term thing, like layman's terms books. Like, I'm starting to love Sean Carroll's latest series. I think it's called I forgot what the title is called of the book series. I think it was called like Big and Small Things About the Universe. Let me take a look. Because I have two of those books. I just don't remember the name of the series. Because I'm waiting for his third book to come out. Let's see. Sean Carroll. The Biggest Ideas of the Universe. Like, I'm really into that book series. I'm waiting for his third book to come out. Actually, I don't even know if it's ready for pre-order yet. The Biggest Ideas in the Universe. Let's see if the third book is ready for pre-order yet. Nope, it's not. Oh wait, is it? Oh no, that's just a paperback version of like the second one. I thought it was a new one. Yeah, I'm still waiting for his third book. I can't wait to read that one, because that one I think is about like consciousness and stuff, or his take of what consciousness is. Yeah, if I were to get into if I was to go back to school and I basically wanted to do a job in like, you know, as someone in STEM, like if I were to be able to get that said job, get 100% guaranteed, I would either be a cosmologist or I would be a mathematical physicist. Those would be my choices, but at the same time, it's like, I don't know, like for me, it's like, I like teaching more than research. But then again, I've never done full out research though, so I shouldn't say that I don't like research. But then again, I think research is fun when you're doing it as a hobby. Like doing it as a job, I think like that takes like a lot of dedication. Especially with universities basically saying you have to print out papers like every couple of I don't know how long they make you, I don't know how often they make you want to write make you have to write papers for the university. But, you know, like for me, I'd rather be like the professor that teaches. But then again, obviously, when you're in a university, you have to do research as well. It's not about just teaching students like it is like for high school or something like that. I don't want to teach like high school or like middle school or anything, because I don't like the curriculum. I want to be able to teach it the way I want to teach it. Yeah, I definitely have to keep it at the hobbyist distance. Yeah, like I have a couple of books like about like some pure maths, and some books on like physics and math at the same time. The thing is that I think proofs are cool because you actually see where the ideas come from, and it's like better than just basically just plugging and chugging calculations, I think. But then again, like, you know, like, I think, like, I don't know, for theoretical physicists, like, I think, like, they mess with equations, but I think they also have to mess with some of the numbers, too. Like, some of the constants in nature. So, I am not particularly sure if they're just messing with just variables. They could also be messing with, like, some values, too. I mean, like, I'm also, like, I think I want to be more mathematically minded because, like, you know, I want to be able to appreciate string theory and basically say, I appreciate string theory, but not for the forethought of saying, oh, it's the theory of everything, so obviously it must be right. I want to be able to, like, look at it from a mathematician's point of view where it's like, it's beautiful, and I want to be able to mess with it. Like, you know, mess with it a little bit. Like, within mathematical ideas as well as physical ideas. Like, I want to understand the physical applications of it, but also the mathematical implications of it. Like, for me, I would probably say that I think, like, out of, I guess, like, the big icons of, like, physics or math, I would say I would feel closest to Roger Penrose. Like, obviously, I'm not a genius like Roger Penrose. Don't get me wrong. But like, the way his backstory was is that he said he was slow in school, and I always felt like I was like that too. Like, I just needed extra time on test. And you know, like, he was also not great at chess either, because his brother was really good at chess, and his brother was a physicist. But then, like, Roger Penrose ended up doing math, so I felt as if, like, Roger Penrose was kind of like, I guess, like, if I was in another universe, I would probably be, like, doing what Roger Penrose is doing. That's because I also want to be able to read and understand Roger Penrose's book. Let me see if I can find it. I think I have it on my computer. Roger Penrose. Yeah, The Road to Reality. I don't know if you're familiar with this book. It's also a big chunky book. Like, I want to be able to read this and understand it. But, like, he also puts, like, a little bit of, like, he puts, like, math equations in it, but, it's still, like, I think for this book, it's, like, manageable unless you know, like, I guess, like, not basic, I wouldn't say basic maths, but, like, math that you would learn on undergrad. Like, I want to be able to read this book and, like, because, like, this is primarily the spell book I want to actually get into. Like, The Road to Reality. Because, like, also Roger Penrose, I think he also created Twister Theory, which I'm kind of curious about reading, but I know I'm nowhere near the level of actually being able to comprehend that theory. But, you know. Okay, I think, like, So I think when this break is done, we're gonna probably do one more session. Let me just turn off the timer for a second, because I will be right back. Okay guys, I'm back. Alright, time for the next session. And I think this will be our last one. Just want to restart my playlist. Like, how far are we at? Alright. Now we'll start the timer right now. Okay, question number 3. Let's get to business. Let me just drag this over here so you guys can see it. Because I know my model blocks a little bit of the problem, so I don't want it to block what you guys see. So, now we gotta do... Maybe I gotta do it the other way around. So... maybe instead of this side, I should do it on the other side. So... if we do it on the other side, then the other side will equate to A. So let's just change these back to the way we had it before. So A would be A plus B plus negative B. Probably should move this a little bit, give more space. So A plus B plus negative B plus AB plus negative A. And then we have the absolute value of C D then minus D C wait a minute. The bottom looks promising, 'cause I mean, technically, since it's an absolute symbol, we can just rewrite it. Because technically it looks like negative. Because technically it looks like that. Now on the top, because A plus and plus negative B then again, they also annihilate. Yeah, like the extra A and the extra B would annihilate. Well, I say annihilate, that's probably not the right word to use. Then they would just be... Yeah, because... Right? I think that might work. I'm just like pondering right now because I felt like we did that the last time and I feel like it should work. And I feel like with negative D and negative C, they would basically be like, it would be C if C was, and then it still would be C. Because the absolute value is, I always write this wrong. Because I'm pretty sure it's right here. Oops. I mean, I'm probably doing a lot of scratch work, so... Because if it's like that, then it's less than 0. And this... If D greater than or equal to 0. Because, I mean, it's still, like, C either way, so it would still be the absolute value. And that would be just minus. But then again... I mean... Technically, it would be considered both equivalent, because, like, they're all under an absolute value symbol. I mean, absolute value, brackets. So since it is that, I mean, did we solve it though? I mean, based on what I'm thinking, it feels like we solved it. Because, I mean, I feel like this A and this B will annihilate the extra stuff here. So this A would annihilate this A, and this B would annihilate this B, and we're left with those. I feel like that's right. And with this absolute value brackets on the side, I feel like it wouldn't really matter if it's like, you know, negative, like if it's the absolute value negative D, because I feel like you can rewrite it because of the absolute value brackets. I think that's it though. Unless I did something completely, utterly wrong. Like, it's like, your logic is off. But I feel like looking it over, it feels as if we did everything right. I think. You didn't show that, let me zoom out. I probably did miss something. More likely I missed something. So I'll just erase this last part. Let's see. The first line you need to prove, so I don't care. The first line is what you need to prove, so I don't care much. Didn't you just show that a... How did you get to the second line? The first line is what you need to prove. Let's see, right hand side is... So we'll erase this part, and we're left with... Ooh. Yeah, I was kind of jumping the gun with that one. So we are left with... Actually, I should move this. Actually, I should erase this. Yeah, I don't need this. Then we are left with... Yeah, so that's what we have so far. Because I'm figuring that because the absolute value symbols kind of make this like kind of it kind of makes it a positive value either way, but at the same time it's like I'm probably like missing something. Because then this could be equivalent to D minus C. And I think like these B's and these A's would annihilate each other, right? So then we would still have like, we can still have this, right? Unless that's not how it works. Gotta turn on the light. There we go. Let's see, A and B equals 2. So I mean, they would be equivalent. Yeah, that would be equivalent. Because like if it was, yeah, it would be like the absolute value of 4 on the left-hand side. So it would be like plus C, and then it would be absolute value of 2 plus the absolute value of 2 over. So practically, yeah, because then it would be 2 in both sides, and then, yeah. So that's pretty much equivalent. Because C and D are not supposed to match. So that works. Now the thing is that I know with the absolute value signs, it doesn't matter if there's like, because it could be turned into this and turned into this. Now, my one issue is that we need to get this to look like this. And based on the logic that I have, I feel as if the absolute value symbols kind of make this a given. But I don't know if that's logically true based on the definition of absolute values. I think that's where I'm stuck at. At the first step, that's true. I'll just erase these. But I don't know if the thing of it is that something in my brain tells me that these two are not equivalent. But I feel like when I actually think about what I know about absolute values, I feel as if it's not really like, I feel like they are based on what I know of absolute values, but at the same time, I don't know if mathematically if that is true. That's the one thing I don't know. But I feel like we're so close though. We're just so close. Like we're so close. We're so close to actually figure this out. But I don't know if I did this right though. This step right. Because I feel like we did that with the last problem. I mean, defining what A and B is. Regarding your C to D issue, you know that... Can you make a relevant choice of X here? Relevant choice. Like, do you mean, like, basically make X 1? Like, I guess calculating wise, because you're trying to help me, like, think of it in that type of regard? I mean, we can't have D and C equal 0, so... Because then, if you had... Let's say if you had D equal to 2 and C equal to 1, then the absolute values of those two I'm trying to make sure I reread everything you're typing, and Stunky, so I know exactly what you're asking. So that way, like now I'm actually like trying to think about exactly what I understand and what I don't understand. But yeah, like, I feel like, yeah, like the negative, these would be equivalent to these. Because, the absolute value, I believe, is like, if it's like a negative sign, it doesn't really matter. It will always give a positive value. Because I think, like, even if you put so if you say, like, D is, like, 2 and C is 1, right? Like, 2 minus 1, that would be, like, 1, and that's the absolute value of 1. And if you switched it around, basically you had, like, C equals 1 and D equals 2. And then you basically put C, like, basically put 1 minus 2 for the other scenario. Then that would still give you 1. and then that would give you the positive distance because they were all in absolute values symbols. So I feel like they are equivalent. Because I feel like they are equivalent to each other. I mean, thinking of that logically. But if I totally missed something, then I'm pretty sure you would be able to see it. And I think you already see it, I guess. Because maybe there's a gap in my logic here. Because so far, like, what I just tried to do was basically prove the right side. So I tried to prove the right-hand side here. But then again, it doesn't give us... I mean, all they did was just prove that the right-hand side is just equivalent to its own self, yeah. But I see what your point is, yeah. Maybe I'm approaching this wrong, so maybe let's just erase this for now. Let's just erase this part. So... Because maybe I'm just like tantalizing myself here. So maybe we have to prove that the left-hand side is like the right-hand side in some way. Because I think I tried to break it down with this one, but then I only end up proving that the right-hand side is a good equivalent to itself. Yeah, that's a more pressing issue, unfortunately. Yeah, real quick, standard trick for inequalities, yeah. Alright, so we gotta actually get this to match this in some way. I think that's like a more obvious approach. So... Oops, no, not B. It's D. It's D. Okay. Now, huh. I mean, if you were to turn for some reason, if you were to turn and plus, it would still be AB plus negative A. remember that this is all they're both in absolute values. If you want to know that A over B is less than or equal to C over D, it's enough to show that A is less than C, and is that supposed to be an exclamation point within parentheses? D is less than B. In other words, to go up the less than or equal sign, you need to make the numerator bigger and the denominator smaller. Huh. Now I just gotta figure out what this part would be if, I mean, because we know what the absolute value of A is. Because if this is equal to this, so that means that if this must be equal to A minus B. Show C is, let's say C is equivalent to this, then C minus D, that would equal I think we're getting close. I'm trying to actually incorporate what you typed and Stunky. If you want to show that A over B is less than C over D, it's enough to show that A is less than C and less than or equal to C, and D is less than or equal to B. In other words, to go up the less than or equal sign, you need to make the numerator bigger, reasonable, and the denominator smaller. I mean, we could rewrite this as so we got the bottom part, it's just the top part. we see this in the triangle inequality before? Or one of them, anyway. Should be less than or equal to. Okay. But in our problem, we have to prove that it's like two separate entities. We actually have to do this scenario again? Maybe. these two would annihilate each other. Now we're just like struggling with the top. Maybe this is not the right approach. So close, but yet there's something that just doesn't feel right. Take a look at the other problem. Probably next stream we'll probably like. I mean the Math Sorcerer does go over these problems, but I don't want to like look over them until I actually like solve them. I don't want to look at the solutions right away. Because I've been pondering over this problem for like practically the whole study session. Let A be a positive number. Prove that if X is a real number such that. Okay, and then A is greater than A and a half, or A. Why you say yay yay? Why you say yay yay in Stunky? Like going to the next just skipping that, like just putting that problem down for now and just going to the next one. Okay. Yeah, this one I was struggling with since the beginning. Okay. Let A be a positive number. Agreement noise. Oh, okay, okay. Now this one is like a little, because like when they say a positive number, do they mean like a real, like, I'm guessing they mean like a real number, right? Because like obviously I don't think an integer is going to be like, the absolute value is going to be like less than, so I'm assuming it's a real number, like a real positive number. That's what I think they're meaning by like it's less than a over 2. So suppose that. So the thing we have to approve is this part. So actually the question is that what is the absolute value of this? That's a real question. So it's supposed to be less than a and a half, or a over 2. Yeah, I don't think we're gonna finish this one because we only have 2 minutes left, but we'll try our best to brainstorm like at least the beginning step. Actually, like guys, like I have to ask you a question. If like I know we're not gonna finish these problems like on this stream, but do you think I should save these problems until tomorrow's stream, or should I just like look over the answers and like review it by myself and then we do something else for tomorrow's stream? What do you guys think? Because I felt like I haven't done much. I've just been like pondering so much throughout this whole entire like study session right here. That I should be writing a little bit. So, unless my brain is completely fried right now, but I guess math always does that. What did I define this as? Because I mean, if it was just x, right, then it would be just x plus a plus minus, yeah, minus a. But then again, it could also be, could be a plus a, which can also be converted into plus a. So that would mean that the absolute value Right. I guess that ends our, how long have we been streaming? 3 hours, wow. And I have to stream 3 hours again at 8 o'clock on my second channel. Oh my gosh. I honestly, oh, hello, oh, Femvox. Hey, how's it going? Oh, I can't follow because I haven't verified my phone on Twitch. Yeah, like, I kind of put that there. I probably should turn that one off. I think the reason why I put that there is because, like, some people watch Twitch on their phone. Because, like, I'm afraid of bots. That's why I haven't, changed that up. I probably should change that, actually. Because I forget that some people don't use, Twitch on their phone. But how are you doing, VanVox fam? How are you doing? But you know, we solved one proof, so I guess that's an achievement. Oh, no problem. I thought it might be a new Twitch setting. No, so I set it up that way, but if you just have an email address, I think that should be, like, okay. But then again, you know, but I'll probably will change that, actually. Moderation. Now I gotta find where I actually have that. Phone verification. Oh, that's weird. I have that off. I have that setting off. It just basically... I just basically have verify an email address. That's weird. All chatter must verify a phone number. Yeah, I actually have that option off. I thought I had it on. That's weird. But welcome, Venvox fan. It's good to see you here. But unfortunately, we weren't able to finish all the proofs in this problem set. We only had like 3 proofs to do, and I only managed to get 1. But I think that's an achievement, I guess. But N Stunky basically helped me a lot. But thank you, N Stunky, for basically trying to be the support as well as the helpful guide, because I know you guys are much more brilliant at math than I am at this current stage. But, you know, yeah, but it's kind of weird that it basically asks you to verify a phone number, because I don't have that setting on. It could be, yeah, it could be like the same thing, like you said, like a Twitch thing. And plus, I'm not affiliate on this channel, so, you know, it could be just that. But how are you doing, Venvox fan? Like, what's the best part of your day so far? Yeah, that's weird that it won't let you follow. That's but like, even though you said you want to follow but you can't, like, you know, I understand. Thank you for trying to follow. Happy to see your stream. Oh, thank you. Happy to see you here as well. Yeah, like, basically the only proof I managed to solve was I should probably get my pen again. Was only this one. Our first proof solved on stream, just this one. Let's see. I've been hanging out on various Twitch math streams all day. Nice. Yeah, like, for me, it's like I want to be able to understand the basics of proofs. So, because here's the thing, guys. I want to ask you guys this question, since there's like a couple of you in chat. Should I leave these problems for tomorrow's stream, or should I just like go over the answers? Like, should I just like look over the answers tomorrow and then just, like, you know, learn from what I could not figure out tomorrow? Because, like, I think the Math Sorcerer posted the answers to these problems, like, on on the Udemy course that I have. So I don't know if I should just, like, try to struggle through these problems tomorrow, or I should actually, like, just go over the answers that I missed, so that way I can move on to the next topic. What do you guys think? Because I felt like I was pretty much done after I was struggling with number 3. I can't write Americans be milking. I don't know what you're trying to type there, and Stunky. Yeah, like, I'm wondering what you guys think I should do for, like, next stream, because I feel like for me it's like for me to actually, like, get better, I know that I have to, like, focus on, like, struggling these things. Oh yeah, it is a Martin Luther King Day. in the US, yeah. I almost forgot about that. Thank you for reminding me of that, actually. A day to a great man. Yeah, so like the thing of it is that like Venfox fan, like, so like I've already said this like twice, but my goal with this channel is just to be able to like understand enough math so I can actually start learning. Well, I can start learning from this book now, but at the same time it's like I want to be able to learn enough math so I can basically wait. Oh dang! I always hate it when I misclick. So I can understand this book, or at least do problems in that book. Dang it! I hate it when I misclick. This book, Mathematical Methods for Physics and Engineering. Both. Actually, I'm trying to learn enough math so I can understand theoretical physics. Or mathematical physics. I guess that's my hobby goal, as it were, because I'm more of an intentional person. That's why I don't set goals, because I know I'm not going to be better than any of you guys, because I'm pretty sure a large majority of you are probably very brilliant at math, like at least proving things in math. Because like for me, it's like whenever I do calculation based math, I think that's when I started hating math, because I always hated that I would miss one thing and then suddenly it just messes up the whole problem. And it's usually whenever I get long-winded by doing a process. Because I know with Calc 2 stuff, I have to review a lot of integration techniques, especially like trig substitution and I think integration by parts. I know, like I memorized like the general form of it, but I haven't practiced a lot of that. I have to practice integration by partial fractions. That one I have to practice more. I also have to practice more on trig integration. You know, when basically like, you know, you have sine to the fourth power. Yeah, when you have sine to the fourth power with cosine to the second power, you know, all that jazz. And also I want to get into differential equations. I know how to solve, I think, like the integration factor with differential equations, along with separable differential equations, but I have to review, I think, exact solutions with differential equations and some of the other stuff. Yeah, it's like around 13,000 pages. Yeah, because I want to be able to learn enough math so I'll be able to understand that book, along with this book, The Road to Reality by Roger Penrose. I really want to be able to understand this book, because this book is not meant to be a textbook, even though it's the size of one. Because Roger Penrose does go a lot into, I think, like the mathematical, like I think like the physics / mathematical side of, like, you know, theoretical physics in this book, and I really want to understand this book, including this book, because like even in the primary algebra part, he talks about, like, the authors talk about polynomials, but there's a method of like finding out what the zeros are that I'm not familiar with. Like, obviously, like for polynomials, we know how to get the zeros through factorization or grouping and stuff. But when I read this part, I'm like, how do you get this? Like, how do you get this part? Like, I know what the summation symbol does, and I know what the product symbol does. The thing of it is that I don't know where this comes from. I'm like, where does this come from? And like, how do you calculate this? That's the one thing, like, I'm just like kind of lost about in this part. And in this primary chapter, you do trig identities, coordinate geometry, partial fractions. Those I have to review. Exponential expansion, that should be fun. Properties of polynomial, like, I have experience with those, but because of the way this book is structured, it feels as if it's like meant for people that kind of understand, I guess, the deep intricacies of I think deeper mathematics, like I only have like basic knowledge of like algebra and a little bit of calculus, so I feel like I have a long way to go before I can actually understand this book. It's basically the solution to the system of equations and polynomial coefficients. Yeah, because like whenever I look at my algebra books, I do not see anything resembling this. I mean, I was able to look into, I think, a multivariable calculus book. I think it was proof-based because it showed this and it broke it down with an example, and I was like, okay, so that's what that means. The one thing I don't know is that how do you actually come up with the amount of times that you do the sum of this, like do the sum of this part. And I think it has to do with the amount of degrees within the polynomial, I think. But, you know, I'm just spitballing. But yeah, like, getting back to my previous question, guys, do you think I should just try to continue these problems tomorrow's stream? Or do you think I should just, like, watch the solutions and just try to learn from the solutions and move on to the next topic for tomorrow's stream? What do you guys think? Because I feel like if I know with math, you're supposed to, like, focus on the problem and fixate on the problem until, like, you know, you're red in the face and you actually, like, get it. But for me, it's like, I've done that so many times that I feel as if, like, I should just, like, skip and move on. But I don't know if that's this is one of those scenarios. I know I've probably asked this question, like, many times, but, like, I feel like it gives me preparation for, like, the next stream. So I just want to know what your guys' opinion of it is, because you guys seem to be more experienced in math. So should I just continue with the struggle, or should I just, like, look at the solution next stream and then move on to the next topic? I'm only just here, so I can't really comment on what you should do next. I mean, that's fair. That's fair. Like, I'm just asking for suggestions, mainly, because, like, since you guys have watched many math streamers before, like, this is, like, my first channel doing, like, dedicated towards math, so I don't know what would be, like, you know, what exactly you guys are expecting from a math stream. So I want to make it, like, at least, like, a decent stream so you guys can get your fill of it. I tend to be the kind of person that doesn't go to the solutions, but sometimes that means that I just abandon problems instead of completing them. Yeah, like, I get that. Because for me, it's like, I feel like I shouldn't look at the answer, but at the same time, like, I'm the type of person that would never look at the answer until, like, it's a really, really long time that I haven't figured it out. So I think, like, probably tomorrow we'll probably try it again. We'll probably try to fix, for the first study session, we'll probably just try to fixate on trying to solve these problems. And then probably, like, during the break time, we'll probably in the next study session within tomorrow's stream, we'll probably look at the solutions. We'll probably look at the solutions, and then we'll try to learn what we missed for that. Alright, so break time is over. I'll turn off the clock. So thank you guys for actually being with me today. I will be streaming on my second channel. It's called Uncle Talks. If you guys like gacha games, you're more than happy to, like, give my Uncle Talks channel a follow. I play games there and also talk to, like, you know, chat there as well. So but for all of you guys in the chat, thank you for being here, and hopefully my stream was enough for you guys to be productive on your own end, whether it be math or whether it be you guys doing, like, an art project or something in the background, or just doing stuff that you guys need to get done. But I really appreciate all of you here. Even if you're just, like, lurking, I thank you for the lurks if you're just lurking. I also good luck with the proofs. Yeah, thank you, Femvox fam. Thank you. And hopefully by the next time, if you're able to catch the stream again, hopefully you'll be able to, like, give me a follow. And for all those that want to keep up with, like, you know, the content that I'm doing on this channel, please give me a follow. I really would appreciate it. Yeah, but I guess that's really strange that it tells you to verify a phone number, which is not what I set up the Twitch channel for it, because I turned that off. I don't know why it's like making you verify a phone number. But I will definitely take a look at that. Yeah, I'll try. I refreshed a few times. It still gives that message. Oh, that's really weird. Let me take a look at it again. I'm gonna take a look at it again, because if it's not on, why would it force you to do that? It might be on my end, so let me just check the settings again. It might be in the security settings. Let me see. Because that is off. Verification exceptions will not be required to verify. All chatter must... Let's see, channel privileges, followers. Ah, here we go. Here we go. So follower verification, that is on. Okay, I just turned it off. So I just turned off the phone verification. So you can try it again, FemFox. I guess like I just had it off for like I think subscribers. So, or like I guess like channel privileges. But I didn't know I had it on for like followers. It worked? Okay, thank you for the follow, FemFoxFem. Thank you very much. I really appreciate that. So having more people join the Math Spellbook community. And also, if you guys want to catch up on what was in this VOD, I will upload it on YouTube. So you're more than happy to subscribe to my YouTube channel as well. So there we go. So yeah. That way we can make the Math Spellbook channels like pop off, and that way I can learn from more brilliant people such as yourselves. Because like I know a lot of people that do math streams, they've already done like their bachelor's and all of their like, well, not their bachelor's, but some. Oh, whoops! I didn't realize I turned on my own stream. Oops. And unfortunately, I don't think we can. I don't think we can. Raid anyone for today. So yeah, so I think tomorrow's stream we will try these problems again, the first part of the study session, and then probably the second part. If we haven't figured it out, we will look over the answers, and we'll probably look over the answers anyway to make sure we're correct, unless someone in the chat corrects me and tells me that, oh, you got it right, or like no, that's not the right approach. But yeah, and I think like after that, like probably we'll move on to the next section of the real analysis course that I am trying to take right now. So yeah, I think that's about it. I've talked a lot. So guys, like I said before, if you want to follow me on my Uncle Talks channel, like when I'm basically just posting games and just talking to you guys like normally, I'll be playing Honkai Star Rail tonight. So yeah, if you want to like check in, watch me play Honkai Star Rail to complete the story, or at least complete whatever I can with the story that's up currently, yeah, you're more than happy to do so. So thank you again, guys, and always remember, everyone is precious. You guys is just as precious as everyone else, and I will see you guys next time. So take care, guys. Bye-bye.